Let's look at another example. Consider a normal deck of 52 cards. How many 4-card hands are possible? So we have a pool of 52. We are choosing 4 cards in our subgroup. So what are the combinations? Is 52 choose 4 is the number of 4-card combinations that are possible. How many of those 4-card hands consist of no aces? So now notice that we have categorized the subgroup. So we've categorized the subgroup to consist of aces and no aces. So we want how many of those cards. Let's read the question again. How many of those 4-card hands consist of no aces? So we want our subgroup to have 0 aces and 4 other cards, non-aces. So we need to have the same category for our main group. So in the deck of 52 cards, there are 4 aces and 48 non-aces, other cards. So this is our main pool, which we have 4 aces and 48 other cards. And in our subgroup, we are interested in the combinations of getting 0 aces and 4 other cards. So the number of combinations are then given by 4C0 for having 0 aces in our subgroup. So we need to choose a 0 aces from a pool of 4. We need to choose 4 other cards from a pool of 48. So it will be 48 choose 4. So number of possible combinations with 0 aces in the 4 cards is given by the product of these two terms. Question 3. How many of those 4-card hands consist of at least 1 ace? Now consider the combinations of 4-card hands. The combinations of 4-card hands are given by this term. The combinations of having 0 aces in the 4-card hands are given by this term. Now how many of those 4-card hands consist of at least 1 ace? The number of combinations will be the difference between the answer to part 1 and answer to part 2. So the answer to part 3 is 52C4 minus 4C0, 48C4. We could do part 3 in another way as well. We are interested in combinations of 4-card hands with at least 1 ace. Now we could have at least 1 ace if our 4-card hand has 1 ace and 3 other cards, or if our 4-card hand has 2 aces and 2 other cards, then we still have at least 1 ace. Or if our 4-card hand has 3 aces and 1 other card, our 4-card hand still has at least 1 ace. Or if we have all 4 aces and 0 other cards, our 4 card hand has at least 1 ace. So these are all possible ways of having at least 1 ace. Now our main pool has 4 aces and 48 other cards. This is our main pool. So in how many ways can we choose 1 ace and 3 other cards? We have a pool of 4 aces and 48 other cards. So given we have a pool of 4 aces, we can choose 1 ace in 4C1 ways, and we can choose 3 other cards from a pool of 48 in 48C3 ways. In how many ways can we choose 2 aces and 2 other cards? We can choose 2 aces from a pool of 4 in 4C2 ways. We can choose 2 other cards from a pool of 48 in 48C2 ways. In how many ways can we choose 3 aces and 1 other card? From a pool of 4, we can choose 3 aces in 4C3 ways. From a pool of 48, we can choose 1 other card in 48C1 ways. In how many ways can we choose 4 aces from a pool of 4? In 4C4 ways. And we can choose 0 other cards from a pool of 48 in 48C0 ways. So the number of possible ways of having at least 1 ace in a hand of 4 cards is the sum of all these terms, which is 4C1, 48C3 plus 4C2, 48C2 plus 4C3, 48C1 plus 4C4, 48C0. So this is an alternative answer to what we presented in the previous page.